So this video is going to be on atoms, and I'm also going to talk a little bit about the periodic table and what the parts of this actually mean. So I'm going to start by showing you guys a periodic table here. And as you can see, I have carbon circled, so I'm going to use that as my example to go through the parts of the periodic table, what these symbols mean, what those numbers mean there. So first of all, if you look at carbon, you'll see right in the center there's a C. Well, C is just the elemental symbol for carbon. It's just a shorthand, so you don't have to write the whole word carbon out. You can just have a little shortened version of it there. If you look right above the C, you'll see the number 6. Now that number is actually referring to the atomic number. So what that means is it's also the proton number. That's how many protons you have in that atom. Okay. Now the number below the C, which you can see is number 12 there, that is the atomic mass. And what that stands for is the number of protons plus neutrons in the atom. So the overall mass of an atom is basically made up of the protons and neutrons. So that's why they make that the atomic mass number. So let me pull up here and kind of go back through that with you guys really quickly. So again, the letter C is just the symbol, okay, for carbon. It's just a shorthand for it. Above the letter C, you'll see the atomic number, okay, also known as the proton number. So this is telling you the number of protons you have in that atom. So that tells us that carbon has 6 protons inside of its nucleus. All right. Also, if you think about it this way, all of the atoms on the periodic table should be considered neutral, right? Which means they should have equal numbers of protons and electrons. So if you think about it that way, then the element carbon should also have 6 electrons found in the atom. All right. Now this number down here at the bottom is the atomic mass number. Okay, atomic mass. So this is basically the weight of the atom, and what it's made up of is the number of protons plus the number of neutrons. So essentially everything that is found within the nucleus of that atom makes up the atomic mass. Okay. So let's talk about the parts of an atom. I've been talking about protons, neutrons, electrons. Let's just review what those are. Hopefully you guys saw this in your PowerPoint already. But remember, there are 3 subatomic particles that make up all atoms. Okay, and those subatomic particles are protons, neutrons, and electrons. So remember, protons have an overall positive charge, so I'm going to put that plus there. Electrons have an overall negative charge, and then neutrons are considered neutral. Okay, so I'm just going to put a 0 there because they do not have a charge, whereas the others do. Okay, so protons and neutrons are found in the nucleus of an atom. Okay, so I'm just going to draw this circle here to represent the nucleus. And you're going to have protons and neutrons found in the nucleus, right, in the center of the atom. Now, surrounding the nucleus, we have what are called electron shells or electron orbitals, okay, and those are going to contain the electrons, okay, so electrons are found out in the electron orbitals. And you can have multiple different electron orbitals. What's going to determine the number of orbitals is essentially how many electrons there are in that atom. Okay, so if we use our example again, carbon. Remember we said carbon has 6 protons, right? Which means that it also has 6 electrons. Okay, so if I wanted to draw an atom of carbon, let's just do that down here, just to give you guys an example. All right, so remember carbon has 6 protons, right? 6 protons. I'm just going to shorthand that like that. Now, if we look at the atomic mass number, we can determine the number of neutrons, right? Because the atomic mass is equal to protons plus neutrons. So if I take this atomic mass of 12 and subtract the atomic number, which is 6, from it, then that will give me the number of neutrons, right? So I also have 6 neutrons in my nucleus. Now just put a plus there. That should be neutral, right? Now don't get this confused, okay? So not every element on the periodic table will have the same number of protons and neutrons, all right? Sometimes you'll have different numbers of neutrons than you have protons, and you might see that as you do some examples on your own. And that's okay, okay? The atom will still be considered neutral. It will be electrically neutral regardless of how many neutrons you have in that atom, right? The only thing that's going to affect the charge of an atom is the number of protons and electrons. Reason for that being because protons and electrons are the only actual charged subatomic particles, right? The ones that actually have a charge to them, okay? So that's the nucleus of our carbon right there. You got 6 protons and 6 neutrons in that nucleus. So we see that we also have how many electrons? We have 6, right? So we have 6 electrons found in carbon. So the first electron shell or electron orbital surrounding the nucleus can only hold up to 2 electrons, always, okay? So we're going to draw 2 electrons in our first shell there, okay, surrounding the nucleus. Now, every shell after the first shell can hold up to 8 electrons. And once you have 8 electrons in that shell, it is considered full or stable, okay? We call that the rule of 8s. Once you have 8 electrons in those outer shells, then they're considered full, and they're not going to want to hold any more electrons, so then you have to move to the next shell, okay? So the second shell, if we've got 2 in our first shell, how many do we have left? We had 6 total, right? So 6 minus 2 equals 4. So here we're going to have 4 electrons in this outer shell. So our outer shell here is not full, which means that this element is not stable. So that tells us that the element carbon is going to be reactive. It's going to want to interact with other atoms and form bonds with them in order to fill that outer shell, okay, what we call the valence shell. So this is the valence shell. It's the outermost shell in an element, okay, or in an atom. So when that shell is not full, when it does not have 8 electrons, then that element is considered unstable. It wants to be reacting with other elements, forming bonds with them. Now, if you have an element where the outer shell is full, so any of these elements on the end, so like helium, neon, argon, all of these guys down here, they're going to have full valence shells, okay, which means they will have, helium only has 2 in its outer shell, but remember the first shell only holds 2 electrons, okay. So helium would be considered full, it's considered stable, it's considered what we call an inert element. It's not going to react with any other element. Neon is going to have 10 electrons, so the first shell has 2 electrons, and then the second shell has 8. So it is also considered full, it's considered stable, and it will not want to react with any other element, okay? But keep in mind that if the outer valence shell is not full, does not have, if it's 2 electrons in the first shell or 8 in any shell after that, then it is considered a reactive element. And that means it's going to be trying to form bonds with other elements in order to help fill that outer shell. Okay, so I'm going to get into chemical bonding more in another video. All right. If you guys have any questions about an atom itself, what an atom is, the parts of an atom, please don't hesitate to let me know.